Our next example shows what a full-blown problem is going to look like in this section. As you read the problem, I think you'll find it sounds very familiar because we really use the same process that we did back in 5.2 to find a probability. There's going to be just a couple of little differences. What we'll notice in this problem is that a sample is involved, and that when we're asked to find a probability, it's about the mean of the sample. Otherwise, very similar. So let's see how we'll use this new central limit theorem idea to work a problem kind of like we did back in 5.2. Number 2 says an American family generates an average of 17.2 pounds of plastic trash each year with a standard deviation of 2.5 pounds. They want us to find the probability that the mean amount of plastic trash for a sample of 55 families will be between 17 and 18 pounds. So, like usual, we have a mean and a standard deviation. What's kind of new this time, though, is we also have a sample size. And the probability we're asked to find involves a sample mean. So when we set up that notation for probability, we still want P for probability and parentheses for of. Instead of just an X, we'll have an X bar. So in between the 17 and 18 pounds, in other words, we're looking for the probability that X bar is between 17 and 18, which is going to be similar to the idea of X being between Z being between two values. In other words, we still need to find the Z-scores, and that'll help us know where to mark on our graph and what area to find. So Z-score for 17, thinking about our new and improved Z-score formula, we want to take the number we're interested in, X bar 17, minus the mu 17.2, divided by the standard deviation 2.5 over the square root of 55. So a little bit different than what we've seen before because of that divided by the square root of n. I like to type it all into the calculator at once. I'm going to put parentheses around the two top numbers. 17 minus 7.2 with parentheses here. And parentheses around my two bottom numbers. So 17.2, close the parentheses, divided by, open a new set of parentheses, 2.5 divided by square root of 55. And depending on your calculator, you might need to close a couple of sets of parentheses here. Mine automatically put one under the square root, so I want to close that. And then I also want to close the pair that's around my denominator. Being a Z-score, we're rounded to 2 decimal places, and it looks like negative 0.59. So X bar of 17 is equivalent to a Z-score of negative 0.59. And then we want to do the same thing for 18, find its Z-score. So start with the X bar number, 18 minus mu, 17.2, over the standard deviation, 2.5, divided by the square root of 55. If you remember how to do a little copy and paste on your calculator, you could pretty easily change that 17 to an 18 and get your new result. This looks like it's going to round to 2.37. So an X bar of 18 is equivalent to a Z-score of 2.37. That means we're interested in an area from negative 0.59, a little bit left of 0, to 2.37, way down the curve there. Looks like a pretty good sized chunk. And we can find that area with our normal CDF command, just like we did back in 5.2. Normal CDF from negative 0.59 to 2.37. So second variables to get to the distributions menu, normal CDF is option number 2 on this calculator, from negative 0.59 to 2.37. So final answer, the area that represents this probability comes out to be 0.7135. The next couple of examples show the same process with different situations. Like this one was a between, the next one looks like it's a greater than. As you're reading through the problem, watch for those two clues. We're talking about finding the probability of the mean of the sample, and you'll also have that sample size. This would be a great time to pause the video, do as much as you can of example 3 on your own, and then check back in to see how we're doing, see if we're getting the same results. Looks like we have a mean of 37, a standard deviation of 4, and a sample size of 25 this time. And I'm noticing in the problem that sample size n and ask to find the probability of the average age are the two clues that help me know that this is a 5.4 problem involving the central limit theorem. So to represent average age, I want to put a bar on the x is greater than 38.2. I need to find out what z-score is equivalent to 38.2, so let's do a little work there by taking the x bar 38.2 minus the mu 37 divided by the standard deviation 4 over the square root of n, square root of 25. So a little scratch work on the side. Start with some parentheses, 38.2 minus 37, close the parentheses, divided by, open a new set of parentheses, 4 over the square root of 25, and that z-score turns out to be 1.5. By the way, if you're having any trouble getting those z-scores, oftentimes folks leave out the second division symbol. Make sure that after the 4 and before the square root, you have another divided by. So an x bar of 38.2 is equivalent to a z-score of 1.5. So let's find 1.5 on our standard normal distribution over here. And we're interested in the z's that are greater than that, so that would be to the right. Looks like we're expecting a pretty small answer. Normal CDF will help us find for sure. We want the area from 1.5 on the left to infinity, or any big number you like on the right. So normal CDF 1.5 comma 1,000. And looks like it rounds to 0.0668. Small number, like we expected since we shaded a small area. On the next page, you'll see a problem that has several parts, and you'll find some similar questions on the homework. They tend to have two parts, kind of like the A and the B that you see here. The thing is, what they'll have us do is maybe mix in some of our old 5.2 questions so we can start to work on learning, knowing which is which, when to use the old z-score formula, when to use the new z-score formula. So why don't you look over these three parts and see if you could pick out the one that is this new 5.4. Good time maybe to pause the video, try to find those two clues we talked about, and see which of these is a 5.4 problem. So the two things we said would be new involved a sample. And the only one here that mentions a sample of 60 people, is the part B here. They give us an n value of 60. And when they ask about the probability, it also involves the mean of the sample. So probability that x bar is less than 105, for instance. This part B would be the 5.4 question out of these three. So with that in mind, maybe you'd pause the video again, see what answer you come up with for part B, and then see about attacking part A and part C. To keep going on part B, we want to standardize. In other words, find out what z-score is equivalent to an x bar of 105. So we want to use our new and improved z-score formula. See if I can squeeze it in right here. We'll have the x bar we're interested in, 105, minus the mean. Up at the very top they gave us was 100, divided by the standard deviation they gave us 15, over the square root of 60. So a little bit of scratch work on the side to find that z-score. Parentheses around the top, new set of parentheses around the bottom. And that z-score comes out to be 2.58. 2, 3. So way over here, and we're looking at all the z's less than that, so everything to the left. Looks like we're expecting a pretty big answer. The only part not shaded is this little corner here. So a normal CDF will help us finish it off. It goes forever to the left, so let's start with negative 1,000 up to our z-score 2.58. Normal CDF, negative 1,000 to 2.58. And it rounds to 9951. I would suggest next trying part A. It's going to be very similar, but it does not involve the sample. So this is going back to what we did in 5.2. And you'll see some questions like that in the 5.4 homework. So maybe a good time to pause the video again, see what you come up with for part A. We're looking for a probability this time that just this one person, so just an X, not an X bar, has an IQ less than 105. We'll want to see what the standard score is for an X value of 105. It's going to look a lot like it did on part B, but we don't need to divide by the square root of 60. So we still have the 105 minus 100 over 15, but just stop there. So 105 minus 100 divided by 15. Looks like an X value of 105 is equivalent to a z-score of 0.33. So 0.33. We're still looking at all the numbers less than that, so to the left of it. It's a good bit smaller area than it was in part B. Still, we can go with normal CDF. The shading continues forever to the left, so negative 1,000 up to 0.33. And that rounds off to 0.6293. So expect some questions like this on the homework, where part A has you use the old 5.2 method and part B has you use the new 5.4 method. I've also thrown in a 5.3 kind of question here. Might pause the video and see if you can remember how that one works. If we're looking for the lowest score that puts you in the top 5%, for top 5%, we'll shade a little bit up at the top or to the right. 5% as a decimal is 0.05. I'm needing to know what z-score would correspond with that cutoff. I know it's going to be positive since it's over on the right hand side. We've got our inverse normal command to help us out. Inverse normal command's a little bit tricky. It does not want the 0.05. It wants to know what the area is to the left of the z-score, even if that doesn't happen to be what we shaded. So 0.95 would be the unshaded area. If 5% is shaded, 95% is not shaded. And when I put inverse norm of 0.95 into the calculator, I get a z-score of 1.64. So if I go back to my formula, x equals mu plus z times sigma, now I have all the numbers I need. We know mu is 100. We just found out the z-score for this one is 1.64 times 15 was the standard deviation. 100 plus 1.64 times 15. And it comes out to 124.6. So the cutoff for the top 5% is a score of 124.6.